Guys, so today we'll be seeing about the Euler's number. So when I was doing some of my tasks, I suddenly seen a formula something like this: 1 divided by 1 plus e power minus value, something like that. So I got a formula something like this. So then, like, this is not the first time I'm seeing this. Like this kind of formula using e exponential, like even in our calculators we'll be seeing e, right? Even in my school days I would have seen e many times, many a times, but without understanding like what is significant about this e. Like I came this far, but today I was very curious and wanted to know like why this e is occurring everywhere. Like I'm like a very normal guy, so like not into any mathematics degree or PhD, nothing like that. So I'm also like you. So and then so that's when I started searching what is this E and the why it's occurring everywhere. So then when I started scrolling, like when I start studying about E, I got very much curious because the first example I seen in the internet, when I this E is nothing but the Euler's number. Okay, there's a guy Euler, is a scientist, so he founded this number, so it's named after his name. So basically, when I got curious is like it came to a real world example where like they are saying, let's say we have a bank. Let me take you that page which I have seen. Okay, this comes to a compound interest in a bank. Okay, let's say you have invested, like don't see this example for now, maybe I will put it here. So let's say bank scenario, let's say you have invested 1,000 in a bank for 1 year, for 1 year. Okay, so if bank is saying they are going to give 100% interest rate. This is not real anywhere, but let's just assume. So bank already said they will give 100% interest rate. So let's say if bank is calculating their interest at the end of the year, right? So at the end of the year total value will be 2,000, right? Because it was 1,000 your principal, and with 100% interest it is 2,000. Let's say bank is saying your interest is compounded half yearly. Here interest is compounded yearly. Okay, this is yearly. Let's say bank is saying they are going to do it half yearly. In half yearly what will happen, like in the value will become, so after 6 months, half year means after 6 months they are going to do a value, right? So after 6 months actually your principal will become, for 6 months, right, it will be 50%. So your principal will be become like 1,500 after 6 months, at 6 months. Okay, so let's, when in 1 year what will happen, because it's half yearly, they will interest 2 times, right? So this, the second, after 6 months your principal becomes 1,500. So after 1 year, for this 1,500 you will get again 50% interest, right, which is 750. So your total interest principal will be 2,250, like when the end of 1 year. So thereby here, when it is half yearly, you are actually earning more, you are actually saving so much money, right? 250 rupees more than yearly. Same way, so when many a times when bank is doing this compounding like yearly, half yearly, if they are doing it like quarterly or monthly, right, whenever they are doing this interest compounding multiple times, then our principal also doing will increase that many times. This is the beauty of compounding. So let's say, so this can go up to infinity, right? Let's say if it is going to 1 day, let's say 1 second also, even if it goes 1 second, or like even milliseconds, right? So they are saying even though it's going to milliseconds, the max amount that you will be uh, earning with this is e to the power of 2,000. which is 2.71 star 1000. Okay. uh yeah, so like 2.71 times this one, which is 27100, right? 0. So this is the max interest that you will be getting into 2.7. Yeah, so yeah, this will be the maximum amount that you will be getting as per Euler's rule. So they are just directly saying this will be the max value you can get using Euler's formula. But I doubt that. So I just calculated actually, but still I got the same value. Let's say 1 plus. So in bank the common interest formula is this. Common interest formula for a bank is this one, where this is the interest rate and this is the how many times you are actually doing. So let's put 1, since actually interest is 100, right? But since we are representing it in decimal, it will become 1, so it's 1 by 10, right? So if you just calculate this, right, 1 by 1 plus 1 by, let's say this is 1 year, first for one, just 1 year once, this formula, right? So this will become 2 into 2, right? That is just 200 into 2, which is the 1 year, right? If it is become half year, if this 1 becomes 0.5, because if it is half year it will be 2, right? This half year, like this is like 2 times they are paying. This is that n, which can go infinitely, right? Because interest will be common across all the calculation, but just this value 1, 2, this can be 3, 4, so this can grow infinitely. So whenever a variable is growing infinitely, it can grow only up to 2.7. That's what they're saying. So let's see that. So like if it is 1 by 2, right, 1 plus 0.5 is 1.5, 0.5 divided by 2 is what? 0.5, 1.5, right? Actually I might be wrong here. Let me go through the, yeah, if it is r by n, the whole power n, that's the formula. R by n, this is the like common interest formula, n plus r by n, actually whole power n. N is what? Let's put the formula here first. 1 plus 1 divided by n. This is the like this. Actually, this Euler's will be used in many places. This is just one such place, which is in the common interest calculation. Okay, so let's go with this formula. So they're saying, so as I said, let's say interest rate is 1, like since it's decimal it becomes 1. So 1 by 1, this is 2.25 when it is like half yearly calculated. When it is calculated like monthly, it will is 2.61, right? 2.61 is here 2600. So if it is like 10,000 times a year, still it will become only 2.71. So 2.71, yeah, 1000 times, right? 271. Even in 10,000 it will be 2. So the bank amount every second or millisecond, the max amount, that max benefit that will be getting is 2,710 when you invest 1,000. So this is like some beauty, right? This number, they were already, without doing any such calculation, they directly told if values increasing infinitely, in such cases it will only go till 2.71. So this is a magic number. So once they know this 2.71 will be that limit, so they will, like, they can blindly use this magic number like in many formulas, physics, data science, everywhere, right? Yeah, so this is something I wanted to share with you today on what is this Euler's number. So let me take you to other examples also. So even like when this is like this, these are some kind of formulas we'll be using across in data science and other places. So here also if you see this n, this is like almost same as our common interest formula, right? So the maximum number will be 2.71. Okay, so whenever you are finding hereafter e in any of your formulas or in the calculator, you should know e means your value will be like let's say e to the power of 2, right? E of 2 means what will happen is it will be like e is e to the this is nothing but e to the power of 2.71. You should know that if it is e to e of 2, you should know it is e to the power of 2.71. And why this 2.71, why e means 2.71, we can blindly believe, right? So that's why we got this example. So this 2.71 is like a magic number, but in real actually it works. So that's why this 2.71, like this is, so this 2.7 is denoted with the e in max, and like for the simplification this is used across all the formulas. So maybe with this I can also tell you some other things related to data science. Okay, let's say, okay, like this is about normalizing. Okay, let's say like usually from data engineering or like real data, right? Let's say customer data, customer can have any kind of data, right? Age, height, anything, right? So each age can be like 30, height can be like 170, right? Or age can be 1, height can be like 10 centimeters, something like that. So these two are like in different scales, right? This is just two fields, so these are in different scales. But whenever we are before applying this to a machine learning model, like we should normalize it, because most of the machine learning model works well with normalized data. Normalized data means like put all the features, they, because machine learning model don't know whether it's age, height, because they can't understand, right? Age means okay, this is a person, a living human will be aging every year. Height means like their height, this like the each person's height can differ, or like based on geography height can vary. There are so many things on height, right? So machine learning model don't understand any of these things. So for it is just a value. So for it to give equal importance to each of this feature, we need to input all these features into in a normalized value. Like let's say 0 to 1 is the standard normalized value. So what we will be doing, we will represent each of this feature in a 0 to 1 value. Let's say like 30, 170, right? For normalizing it, the main thing what people will be doing is that like n, let's say the n is the value, or we can say value divided by value minus mean. So this is some sort of, when we do this, what will happen? Let's say if a guy's age is 30, but the mean age is like 40, mean minus value. Yeah, so if it is like mean is 40, right, and he is 30, this is like 10. Value is 30, mean 40 minus 3, this is 3. This is basically okay, but this is wrong in a way. So 0 to 1, Okay, sorry. Mean minus threshold value divided by value. So this is the function. Sorry, this is the formula. This is the formula to normalize a value, which is mean minus value divided by. So let's say the value is like, let's take this example. 30 is the value, like age, and then the mean can be like 40. Let's say 40 years of age is the mean. So 40 minus 30 is like 10 divided by 30, which is 1 divided by 3, which is 0.35, something like that, right? So we have normalized this 30 to 0.35. Same way, let's say 170, right? So let's say mean across the class is like 180 or something, or let's go lesser, like mean is 160, but this case age is like 170, right? So it's minus 10. Minus 10 divided by the value is 170, which is 1 divided by 17, right? It should be like close to 0.01 or something like that, but it's a negative. So what we are doing, actually we are making it 0 to 1 or minus 0 to like minus 1 to 0. So it's anyway normalized, right, between minus 1 to 1. So this is normalization I was talking about. So this is a major thing in data science, like this kind of basic one in data science. Everyone should understand this normalization whenever they are working with machine learning models. Okay, even in normalization we have other things also. This is not only normalization. Here we also know, like with just this 0.01 or 0.2, right, we can understand how far this. Okay, this is just with respect to normalization. Okay, so this is respect to normalization. So let's go through other topic, which is scoring. Score, something like that. So let's say, so here it's the same 30 and 70, but let's say here the use case is this is like a rule based scoring, where we want to alert customers who are above like 60 and above 180, above 60 years of age, and height is above 180 centimeters of height. Okay, so the threshold given here is, so that means for all, if they need to alert, they need to give us a threshold, right? So threshold age is 80 and threshold height is 80 comma 180, right? Height is 180. So let's say this is the threshold, right? So here what we need to do is, we need to actually check how much each customer is, how each customer is deviating from the threshold. That's what we need to calculate here, because there might be like half of the customers might be deviating from the threshold, but we might want to only take customers who are deviating much. That means based on this value, right? Like the formula is almost same, just that instead of mean we'll be using threshold, but this will still resembles based on this value. Let's say value 0.2 or 0.8, right? Like just for example, 0.8 means this guy is deviating more, like whenever this value is more, like sometimes it can be 2 also, because if the threshold is like 80 and this guy is like 10 years of or 20 years of age, right? So 80 minus 60 divided by 80, it's okay. But let's say threshold is 80, but let's say the customer is like 180. This is not real, but let's say it's 180 years of age. So it's 100 divided by 80 is more than 1, right? Let's say 1.2. That means this guy is deviating more, this customer is deviating more from the threshold compared to this guy, but both are deviating from the threshold, but this guy is more. So when we take the rank the customers by the score, and if we take top 5, we'll get the top 5 list of alerted customers. That's this scoring basically. Even in the scoring, like after calculating the score, even this score can go up to 1.2 or 3 also based on the threshold and the value, right? Though it won't, it's normalized already, it will still, it can go up to like, because this is not the mean, the threshold. So this can go up to like more numbers, like maybe 3 4 based on the because these are outliers basically, because the normal ranges won't be 3. The threshold should not vary this much. This much guy cannot be more than the threshold. If it is more, it's an outlier, right? So this is kind of outlier. So we might do one more step, which is applying sigmoid function on top of it. Applying sigmoid function on top of this. Applying sigmoid function on top of this to basically normalize to 0 to 1. This is like here there are chances it will go both like above 0 and 1, right? But this is like strictly 0 to 1. For that we will be applying sigmoid function. Like that is the formula for sigmoid function also, which is 1 divided by 1 plus divided by e power minus the score. Let's say the above one is the score that we calculated. So let's say this is the 1 divided by 1 plus e power of 1 divided by 1 plus 1 divided by 1 plus e power a of, yeah. So this is the formula for the sigmoid function. So this sigmoid function will make sure the final scores are 0 to 1. And then yeah, this again like to normalize it to 0 to 1, if we still want to, we can apply sigmoid function. This will make sure it will be 0 to 1. How? Because the score, it can be 3 or 10, anything, right? We are putting it as minus. So this is like e, right? So 1 plus like let's say this is 3, the corner case. So 3 to the power of 2.71 will be like 3 square is 9. It will be around 10, right? So it is 1 divided by minus 9, which is like 0 point, right? Let's say this value is like very less, 0.1, right? So this is still 0.1, 1.1. 1 divided by 1.1 will be still. So like this 1 plus is this e power minus can be any value. It can be like greater or lesser, any value, but it should be more than 1, right? Because here this is 1. When this equation can go like more than 1, the result of the equation, when the base value, which is the divisible, the value, this part which I am selecting, is getting less than 1, then like when 1 divided by 0.2 will become 5, right? Then the result will become more than 1. So for that we are, by adding plus 1 plus, we are making sure whatever the e to the minus 1 score, minus score will be, this will be always greater than 1. So the output will be always less than 1. So it will be always 0 to 1. Yeah, that's pretty much about this. Yeah. So basically in this video we have seen what is Euler's function, like to understand like how a layman can understand. In that way we are explaining, and like some wonders about this Euler's function, Euler's number actually, and then like normalization, and then like scoring, and then again like normalization on top of scoring, sigmoid function. So the function that we have seen at the end is sigmoid function. The sigmoid function is basically used in many places, basically like in many algorithms, like natural language processing, any algorithms where the input should range from 0 to 1. That's when the algorithm might work well. So in those cases, or to get rid of the outliers. There are many cases for that as well. Let's see those cases also. So the sigmoid function will be and function use cases. Okay, let's just ask ChatGPT what it's saying. Yeah, we see machine learning and deep learning. For as activation function, yeah, this is basically to normalize between 0 and 1. And then logical regression, here also like the model requires input between 0 to 1, so we are applying sigma function to make sure the input will be 0 to 1. This again into max. So like most of the places, like to normalize a value, we are using sigma function. It might also always be the best choice. Other functions like reno or okay. So this is the sigmoid function, but we have other functions like relu function. The basically the one we did for normalizing at first, right? Which is plus or minus value. This is basically a relu function also. Yeah, basically this is also a relu function. So we are using relu function and then sigmoid function as well on top of it. Yeah, that's pretty much, guys. Thanks for listening for throughout the video. Thank you.